Hi, do you have any
Yeah,
bottles or
it
cans?
should be right there.
Oh,
Yeah, right there. You got to start recycling paper.
yeah.
I got plenty of that.
Oh, yeah.
All right, so we are getting into straight linear automobile depreciation. I think this will cap off what we will cover in this section before we quiz it out. I will not even give a quiz yet until I am back in the classroom in this one, which should be soon. Hey, you guys. Hey, guys, you can turn on the light if you want. So it says, suppose that you purchase a car for $27,000. According to your online research, this makes a model of car losses of all of its marketable value after 12 years. Model of car losses all of its marketable value after 12 years. That is, it depreciates to a value of $0 12 years after purchase. If this car depreciates in a straight line form, what are the intercepts of the depreciation equation? So this is just by our basic algebra and how we will set this up. Okay, so I'll graph it out first. Okay, so at 0, we're at $27,000. And then after 12 years, we will be at 0. So okay, so that's what we call a straight line depreciation. 0, it's brand new, it's $27,000. This right here is our years. Okay, and this is the value. All right, that's all you have to do. Or if you wanted to write this as our intercepts. Okay, intercept, y-intercept. And our x-intercept is 12, 0. Okay. So we want to determine the slope of the straight line depreciation equation in the situation in example 1. So we take our rise, our change in value, y2, y1. So we could make this y2, y1, x2, x1. So we'll use this formula that we have up here, y2 minus y1, 27,000 minus 0, all over 12 minus 0. Okay. And that's going to give us $2,250. So that means each year the car is losing value of $2,250. Okay. Let's do this next one. Write a straight line depreciation for the equation, discussing example 1 and 2, then draw the equation of its graph. Well, we kind of already drew the graph already, but I'll draw one anyways. And then we'll come up with an equation. 27,000. That's 12. This is years. And this is the value. Okay, so straight line, we use our y equals mx plus b. So our y is equal to our slope. This is also our m over here. And it is depreciating. Okay, so we need, since it's depreciating, we need to put a negative in front. So we have negative 2,250 plus our y-intercept, which is 27,000. Okay, and that's it. Okay, so just since it's depreciating, we need to put the negative out in front. All right. Let's do this one. Suppose Jack purchased a car 5 years ago at a price of $27,600. According to the research on this make and model, similar cars have a straight line depreciation to 0 after 12 years. How much will the car be worth after 66 months? Okay, Okay, so after 12 years, it's 0. So here's our y-intercept. 0, 27,600. X-intercept is 12, comma 0. We'll draw it out just to help us visualize this a little more. So, hey, Ryan, how you doing?
Snowy today?
Hopefully. So that's what it looks like right here. So same thing. We need to come up with our straight line depreciation equation. What we have here. So let's figure out our slope. Let's do. It's actually 0. Oops. Let's get a negative this time. So it's going to be y1. Or here we'll do 0 minus 27,600, and then we're going to do 12 minus 0, which is just negative 27,600 divided by 12, and that's going to give us negative $2,300. So that's how much it's depreciating every year. Let's come up with our straight line depreciation from it. So y equals, we're using our y equals mx plus b. So negative 2,300 x plus 27,000. Okay. So we need to know 66 months. Okay. Now this is in years. Okay. We calculated this in years, so we're going to have to figure out how many years is 66 months. So how we figure that out is we'll take 66 divided by 12, because that's 12 months. So that gives us with 5.5. So it's 5.5 years. So we'll just plug that in. Y equals negative 2,300, 5.5. Plus 27,000. So y equals, after we plug it in, 14,950. So that is what the value of it will be worth after 5.5 years. Okay. So all we have is 2 more. Okay. So we have the straight line depreciation of a car's y equals negative 4,000x plus 32,000. And approximately how many years will the value of the car decrease by? 25%. Okay, so the original one is 32,000. So we need to figure out how much that actually is going to be. So we'll take our 32,000 times 0.25. Okay, so that's how much it's going to decrease by. So it's going to decrease by 8,000. Okay, now that's how much, not how much it's worth. So we got to figure out how much it's going to be worth. So we're going to take 32,000, subtract 8,000, and we get 24,000. So that's how much we need it to be worth. Okay, this is our straight line depreciation. So we'll take 24,000 equals negative 4,000 x plus 32,000. Okay, and we're just going to solve for x out of here. All right, so we'll subtract 32,000 from both sides. Okay. So we subtract 32,000 from both sides. We get negative 8,000 equals 4,000 x. Solve for x. Okay, this is a negative. So x equals positive 2. So it's going to take 2 years to depreciate by 25,000. Okay. All right, so we are on the last one. Okay. Oops, I'm running out of room. Celine bought a new car for $33,600. Okay. She made $4,000 down payment and pays $560 each month for 5 years to pay off her loan. She knows from research that the make and model of the car she purchased has a straight line depreciation and straight line depreciates to zero over 10 years. Create an expense and depreciation function, graph these functions on the same axis, interpret the region before and after the intersection. So one, we want to create an expense and depreciation function. Okay. So one, let's look here. It is depreciating, expense. So expense, it's $560 each month and 5 years to pay off the loan. Okay, so when we start it all off, so this is part one. Okay, this is our expense. So y equals 560x, because that's how much we're paying each month, plus 4,000, because that's how much we came up with first. So that's our expense. Now this 4,000 is not going to be every single month, but the 560 is. So depreciation, okay, our depreciation, we need to come up with a slope of here of how much it depreciates. So again, we had 0, 33, 600, and it's 10 years, so it's 10 comma 0. So it's basically going to be, so if we did this in months, okay, let's convert 10 years to months. That's 10 times 12, so that's 120. We're going to get our depreciation of a negative 33,600 divided by 120. I'm just not factoring in the zeros, okay? So that will equal 280. So that gives us our slope. Okay, so our slope. This gives us our function of y equals negative, oops, I should have put negative here, 280x plus our y, 33,600. Okay. All right, so the last one, graph these functions on the same axis. So we'll graph these. So there's two things we got to graph. Let's graph the easier one. This is the straight line depreciation. So this is 33,600. And then after 10 years, okay, that's the depreciation. Okay, and so now we have our expense. Okay, expense is 5. Let's start off at 4,000, and it's appreciating by 560. You don't have to be perfect, but this is where it is. That's 4,000, and up. That's y equals 560 x plus 4,000. Okay. All right. So I'm gonna let you interpret this on your own, and that's the lesson for today.